So very warm good morning to everyone over here. And before we further proceed with my talk, I would like to say that let's make this session as much interactive as possible because it will be really interesting for you guys. So today I'm going to be talking about two things. First, what I've learned over here in GeekyAnts in the past 5 months, and second, what my hobby is. So clearly you can see that I've learned react.js over here, and second thing being my hobby, it's about music. So my first question goes out to you guys, like what do you really think that I might have come up with today with combining music and React? Now those who have already had a sneak peek at my presentation or when I'm developing my application, please don't kill my question. So anyone else? So I've implemented a step sequencer. Does anyone know what it is? How is it related to music? Okay, so that's the reason why I'm here today. So before we further proceed, I would like to give you a slight preface of some basic music terminology that will help you understand the working of a step sequencer in a better way. So at first we have BPM, metronome, samples, DAW, and the step sequencer itself. Starting with the BPM, it stands for beats per minute. It's a term that's used to define the tempo, or in a layman's term, you can say the speed of your song. So if you're listening to artists like Major Lazer, DJ Snake, you're probably listening near about 100 BPM. Moving upward, you have Seeb, Rehab, they are playing around about 100 to 120. And then we have mainstream genre for EDM, which is around about 128. We have Martin Garrix, Kashmir. So this is what BPM is all about. Then we have metronome. It's a hardware instrument that's used by music producers to keep track of what BPM they're singing or producing in. So how does it really work? It works in this way. It has a needle which oscillates at a regular interval of time. So whenever it reaches that extreme position, it produces a sound just like that of a clock. So just like we clap, we snap while we're singing, we're also keeping a track of our rhythm. Same way this metronome helps us. Then we have samples. So whenever we're listening to music, we know there are tons of stuff going on, vocals playing, guitar strumming, beats going on. So each of this element is known as sample. So these are some basic samples without which music production is totally incomplete. We have kick, snare, cymbal, hi-hat, and DAW. So DAW stands for Digital Audio Workstation. It's an application that's used by music producers worldwide for music production. So if there's any content creator in the room, he can totally relate it with Adobe products such as Photoshop, Premiere Pro, Lightroom, etc. And the first is Fruity Loops, aka FL Studio, produced by ImageLine. It's written in Delphi. That's what I personally use. Second, we have Ableton Live, that's developed by Ableton itself in C++. And then we have Logic Pro X, developed by Apple in Swift, Objective-C, and yeah, that's much. So this is what a step sequencer really looks like in this DAW. Now it may really seem really simple, but it's really hard to operate. You need a real good knowledge of music theory to work on this. And on a normal day, this is what my project really looks like in FL Studio. Tons of things going on. And just like we have frameworks and libraries to help us make application development easy, we have same way we have different plugins, just like we have libraries for JavaScript. And out of these, you can see on the extreme left hand side is the step sequencer. And nowadays, these step sequencers are really scalable. Based on your project, they can really scale up to as many beats as you want. So now that you have seen what is the step sequencer and what is the UI of it, let's see what does it really do. So back in the days, this is what a step sequencer used to look like. On the right hand side, you can see that it's quite busy around with the grid. And on the left hand side, we have some volumes and knobs to get it working, like controlling the pattern repeaters, quantizing the notes, which are quite musical terms. And so how does it really work? You press each and every button on the grid to light it up, and it draws a specific pattern. And when you click on the play button, it will play the beat as per the pattern that we have made. So as I couldn't really come up with any fancy name, that's what I call my implementation, my step sequencer. And this is what it really looks like. We have a play bar, and then we have a step sequencer itself. In the play bar, there's a play button, a record button to help you record the beats, a stop button to stop recording everything, a metronome button which will toggle the metronome if you want to play it or not while you're producing the beats, and definitely a BPM counter. So here we go into the step sequencer. This is a channel rack, and each bar in this is known as a beat. These are the samples, like we talked about, kick, snare, cymbal. And if you don't like the samples provided by me, you can definitely upload your own. After that, we have pattern repeaters. the volume controls for each and every specific channel rack, and a master channel which controls the overall volume of our step sequencer. So this is what an old traditional step sequencer used to look like a huge keyboard-like instrument. This is what an industry-level professional step sequencer is like, and this is my implementation. So this is the audio library that I've used in my project. It's known by the name of Howler.js, and you can install it via npm yarn or cloning the repository. Now, across this, I've come across really interesting function which is known as audio sprite. So what does it really do? First of all, we can see over here that it's returning a howl object in which we specify the source of the file that we want to play. Then there is a sprite object. Let's see the object's API. We specify the offset, that is the particular instance of time when we want to start it, the duration for which it should play, and the loop. So let's suppose we have a really long audio file, like this is an audio form, and we want to play each and every little instance of it. So let's suppose this is an implementation of audio sprite by the Howler.js itself. So let's just see it.
1, 2, 3, 4, 5.
So you can see that we have a huge audio waveform, and we can chop and slice each and every sound waveform that we want. Now, it may seem really simple to you, but it's definitely used in music production nowadays. So I'll give a quick go through what is I'm doing over here. So this is my software that I use. On the extreme right hand side, you can see a huge waveform that I've chopped, and on the left hand side, these are the notes which will play the chopped vocals. So what I really want to say is that the kind of industry level vocal processing or chopping is done, same can be achieved somewhat with Howler.js. So let's see how does it really work in my application. So this way, like what I really mean to say is that Howler.js is really powerful library. Like there were the ladies saying the words 1, 2, 3, 4, 5. Same way we can chop the vocals this way. And let's have an insight into the code base. So I'll start with the state management. I've used two stores. First of all, the store which is maintained for the play bar. I have maintained observables, namely playing, pause, stop, metronome active or not, stuff like that, to keep a track of what all are the icons that are active or not. And these are the simple functions which will help me trigger all of these. These are the functions which will help me trigger all of these icons on or off, or toggle the metronome, toggle the pause and microphone button, or handle the change of the BPM counter. And then move on to the step sequencer store. Now this is where all the business logic is written. Starting with, we have the observables like channel rack itself. So in my step sequencer, what I've really done is, each element is a channel rack. So there's an observer for that, master volume. This is the master volume at the bottommost point, and then we have a master muted. So let's suppose that I bring my master volume to this particular point and I mute it. So again, to unmute it at that particular volume, I have maintained an observer known as master muted to set back it to that same level. And then we have another observer to keep track whether I'm recording notes or not. Toggle beat bar is a function that will help me toggle each and every beat. And then we have load channel rack, which I am calling as soon as the component mounts to load my channel racks. These are the names of the samples, and there we have the source files: kick, snare, clap, right, trap, kick, which I have imported up above. And after that, I am maintaining an observable, and I'm pushing each and every channel rack with each. And let's have a look at the object that I maintain. Sample name that we are displaying over here, like clap, snare, snap. Then active beats, what all are the beats active currently at the moment. Then beat bars, this is an array of all the beats of a scale of 31. Then sample volume, by default the application has the volume set at 75, as you can see, so that I have hard coded over here. So muted volume, again just like master channel, if I mute it, just a second. If I mute it, so to get it back to the same position, I maintained another key in the object. Then I have a master volume. So let's suppose then if I keep on changing the volumes of each and every individual channel rack, but I further want to compress the sound. So what will really happen is the master channel will come into action, and each and every volume slide will get affected. So let's suppose initially my master volume was at 100% and I decrease it to 50%. So each and every channel rack will be playing at what percentage is of my channel rack over here. So currently let's suppose that this 808 is having a sound of 60 decibels, and if I decrease my master channel to around about this much, like 50%, so it will come out to 30%. At that particular moment, the master volume that you can see over here in the code, it will take place. And there is an Howler object that's provided by the audio library itself. It has a source file and the volume itself. And after that, so let's suppose that I'm playing at any beat. So at this particular instance, you can see that the beat has been lighted up. To play all the samples that are active at this particular moment, I have used a function getActiveSamples that takes beat count, that is the index of the particular beat bar. So let's suppose it's at around about 11 to 12. So this beat count will come into this particular function. It will return me all the samples that are active at this particular instance. Handle volume change is a simple function that will help me change the volume of the observables. Mute volume is really important function. So what I'm really doing over here is, let's suppose I am muting any particular channel rack, suppose like this. So before muting, what I'm doing is I'm maintaining a key in the object by the name of muted volume. What it will do is, let's suppose my ride is at a volume of 40%. So before muting, what it will do is it will set the volume 40 into this particular key and set the volume of the sample to 0. So the volume of the sample has been set to 0, but when I again press on unmute, I'll set the sample volume of the particular sample again back to this particular key that I have maintained over in this. You can see in this unmute volume function. So the sample volume is being set by the key muted volume that is set over in the mute volume function. And then we have reset channel racks. So let's suppose I've drawn a pattern and I want to reset each and every channel rack. So all I need to do is just go to that particular channel rack and just press on reset. And if I've drawn the pattern over whole application and there's a master reset, and this is the function used for that, reset master function. And set channel frequency, it's a really important function that's used in step sequencer these days. So it's really hectic to draw the pattern at regular interval of time. So to make an ease to the user, I've implemented these pattern repeaters which will repeat the pattern at every interval of 8 beats, 4 beats, 2 beats, and every 1 beat, as you can see over here. And after that, we have set master frequency, which is the same function that I'm using to set the pattern for all the channel racks over here. And same function like I was using for unmuting the samples, I have the function for unmuting master. Changing the master volume is the same function like that of the sample. Now let's suppose when I upload any custom sample audio myself, what I'm really doing is, just like I had a function for loading the channel racks, I am maintaining the same object, but at this particular moment what I'm really doing is I'm sending an object which has 2 keys in it, the name of the sample and as well as the base 64 of the sample. So earlier what I was doing is that I was using the direct file import over here, which was done by Webpack itself, but now I'm uploading a sample file which is custom, so I'm using the base 64 of it and setting the volume itself. Now bind key. You can even bind the keys with each and every sample that you have. So let's suppose I bind the key Q. So whenever I'll press on Q, I can press the sample. And to get that particular sample, I've made that particular function get key bind and sample. So what I'm passing is the key code. So whatever the key code of Q will be, it will search, it will traverse through whole channel racks and see which key code is related with each and every sample. So when I press Q, it will show me the sample which is related with that particular key code. Toggle note recording, again that's the observable that I'm using to set the note recording on or off. Then record notes is the function which I'll be using to record the notes. So the parameters are the sample index. So let's suppose that I am trying to, just a second. So I have a kick over here and let's say that I want to record it. So I press on the record button and I click on the play. Before it will play the metronome to keep the user in sync with whatever the BPM when playing in. So whenever I'll press the particular key code which is assigned with that particular kick, it will record my audio. So you can see that at particular instance, whenever I press that key, the sample has been recorded. Wow. So what is the function that I'm using? Is record notes. I'm sending the sample index. So my 808 is near about at an index of 5 or 6. So the sample is index is over here. Now beat count is over there. So whenever I'm playing my step sequencer, I'm getting the beat count, which is this particular instance. And at that particular instance, I'm setting the value over here in this array as true. So basically this whole channel rack is an array of boolean values which gets lights up only when I press on it, and it gets the value set to be true. Now play sample and play beats are the last remaining functions. So play beats is a function which will give me the beat count at which particular instance I am. So the beat counts are this only, the indices of each and every channel rack. So whenever I'll hit this particular instance, the beat will play. So let's create a simple beat. So as you can see that whenever my the slider which is moving across each and every beat, what I'm really trying to do is that so at this instance, what I'm really going to do is that I'm getting all the samples that are active to the corresponding beat count. So let's suppose the beat count over here is near about 10 or 15. So what I'm really going to do is all the samples that are active in this particular beat count, I'm gonna get an array of all those samples and I'm gonna iterate it through them. So while iteration, I'm doing this iteration over here, active samples dot for each, and I'm getting the samples index which are currently active. And this dot play sample will help me play the sample which is corresponding to the particular sample index. So now this I later on explain why I have used this. So I'm getting the samples which is corresponding to the particular sample index, and I'm just using the Howler object that I've used in loading the channel racks. Like you can see over here, this is the Howler object. It returns a function to play the audio, and now you can see that I have hard coded an index that is 4, and this index relate to 808. Now in music production, this is a particular instrument which needs to cut its audio signal before we produce a new one. So like now you can see that each and every time I press the button corresponding to 808, it is cutting the audio signal for itself. So that all the 808s don't get really laid over each over I just forgot it. So what I was really trying to do is like I'm hitting this sample. So if I don't hard code this particular code over this, what I will really do is each and every this long beat will overlay over each other, and this will really mess up in the music production. It will not really sound really nice. So I'm just cutting the audio sample before it is again playing up. So moving into the components, the basic component, this is the root application. Here you can see that I've used in the render function a play bar and a step sequencer. And first go through the functions that are in the root application. So as soon as the component is mounting, I am attaching an eval listener for the key events. Then play beats is a function which will further trigger the function that I'm getting from the store. And after that, we have a handle key event. Now this key event is throttled because if a user keeps on pressing the keys without lifting up his finger, then it will be really expensive for the application to just play the beats. So let's suppose I assign this value q. So now I have throttled this function to play the beat. Like you can see that it's playing really at a fast rate, but it's slow at the moment because I've throttled it. If we don't throttle this function, then it will just straight away waste our CPU usage. So after that, I have made this handle key event. What it's doing is that whenever I'm pressing any key, it is helping me get the binded key sample. So I'm getting the sample index that binded with that particular key code, and if there is a sample index that is related with that particular key code, I'm going to record it and play the beat itself. So moving on to the play bar, in the render function, I have simply used the font terms of 5 to display the icons, and then we'll go through the each and every function that are related with them. First, we have a function to play the audio. So now, like you have seen before recording the notes, the metronome plays. So I just hard coded it this way. I know it's not a good coding practice, but I had to do it. So I've hard coded all the metronome sounds using this function. And before I play any audio, if my notes are recording, I'll play these metronomes for a instance of 4 times. After that, we'll set an observable in the play bar store so that my playing is active. And then I'm checking if my metronome is active and the play bar has started playing. I'll be clearing the interval of the beat. Now let's suppose I have metronome running at this particular moment and I want to play my step sequencer. So what it will really do is, no matter at what instance the metronome is playing, it will reset it. So I'm resetting the metronome. After that, I'm incrementing the beat. So the beats which you see over here, there's a logic that I've written which is corresponding to the BPM. Let's go over through it. So this is the main logic where is everything happening over this. So I'm using set interval to increment each and every beat at a specific regular interval of time. The formula is this one. So BPM stands for beats per minute. So if it is at a rate of 128, it means that it will play 128 beats in a minute. But the rate of playing the beat should be beat per second. Like just we have velocity for vehicles, we have kilometer per hour, same like that. So to iterate over each and every beat, it should be 60 by BPM into 1000 to get the beat per second. Now what I've really done over here is, this would have been feasible if there would have been just 4 beats. So this function would have been playing definitely good. But after that, I've added more resolution to the step sequencer. I have 4 times that of earlier, so it should be 500. Then I implemented even more resolution. It gets to 250, and then for this I have done it 125. So fractionally I have divided this beat increment. Earlier my step sequencer was only just for 4 beats, these one which are lighter. So after that I kept on increasing the resolution of the step sequencer, and while straight away decreasing the delay in this step in the beat increment count function. So handle key event is again the same function which will get the event key code and set the corresponding key code in the store that we have over there. And now there's nothing as such to move to talk about this. Now let's move on to the step sequencer. In the step sequencer, I have maintained the render function like this. There's a channel rack that you can see over here that I have maintained, and along with that I have even implemented a sample uploader, and after that I have a channel rack setting, and this you can see at the bottommost point. So the channel rack and the sample uploader and the channel rack settings are the 3 main components that I've used in it, and these are the simple observables. These are the simple functions which will help me preserve the local state whether I'm recording my step sequence or not, same like that. So moving into the channel rack, I have a font of some icon each for, like, the keyboard button, the music button, and the sample name. This is the render function, and the beat bars is basically an array that I've mapped over here that you can see. And then get beat bar class is basically a class which will help me get the class for the styling of the beats. So like you can see that at every instance when my beat plays, the particular beat gets lights up. So for that logic I've written this simple function which will help me get the particular styling for the desired beat bar. And after that, let's just move into the channel rack settings. In the channel rack settings I have the pattern repeaters. and I'm mapping the pattern repeaters, and it's just a local state of 4 arrays, an array of 4 elements 1 to 48 to help me set the frequency of the step sequencer. I have mapped it over in my render function. After that, we have some simple volume control knobs, and there's just nothing as such. So let's just go through the simple functions that are related with each and every icon. So let's suppose that there is a function to mute the volume. So I'm gonna go over to this. So this dot mute volume is doing nothing but just calling the function that's represented in the store of the step sequencer that we have already seen. So all these functions are doing nothing but just calling the functions that are further set up in the step sequencer itself. So the pattern repeaters are really essential. So like I've said that I have mapped an array of numbers 1 to 48. How I'm really doing it. So this dot set channel frequency is my function which will help me set the frequency of each and every channel rack. So let's suppose I press on 2. The beats will get light up at every second interval. How is this function really working? So I'm going to the set channel frequency. I'm passing an argument for whichever particular beat I am pressing on. So let's suppose 8, 4, 2 or 1. So these particular beats are getting lighted up, and so I'm passing just the frequency count. And as I've said that each and every channel rack is mapped itself over here. I'm getting the sample, just a second. So I'm getting the sample index via props, and using the sample index that's related with the particular channel rack and with the frequency count. What I'm really is just doing it, I'm just iterating through this entire array at every gap of the frequency count. So at every gap of 4, I'm setting the value from false to true to light these buttons up at every interval of 4, 2, 1 and 8 and so on. So this is a simple function for this. So I guess this is this is all about the code base, and let's just move back to the slide. So now what I have shown you is the code base. Now I'll just totally relate it. How is it really related to my my application is how it's related to the tagline for organization. Challenges. So first challenge was to maintain the rhythm of the metronome. How does it really work? So it's really crucial and achieving the actual working of a step sequencer, like it should be able to upload custom samples, pattern repeaters, volume knobs for each and every corresponding channel rack, and having a master channel. Experiments. So experimentation with different web audio APIs and finding the best one, and touching a different genre application development after heavily implemented snake game. Believe me, it's just quite challenging than moving a rattle within confined by 4 walls. So research, half of my homework was already done, having prior knowledge of music production. Rest, I had to research about the best audio API which suited with my product, and then I even learned about how Webpack file imports really work. So what's in it for you? So the DAWs, as you've seen, that these are really sophisticated applications, and the user interface is quite complex. So what you as a developer can do is you can even implement your own DAW to simplify the user interface. Like even myself, I took around about 3 years to get hold of this application. I started music production back in the first year, and I'm currently in 4th. So it nearly took me around about 3 to 4 years to get hold of this application. So you can present your own DAW, simplify the user interface, and even the biggest challenge with them is that they are just quite highly expensive. So if you go in for a fully fledged DAW, it will cost you near about $1,000, and you can clearly calculate how much will it cost in Indian rupees. Apart from that, even the system requirement is just quite high. They are really CPU intensive. So even I myself use an INN system to keep my system out of trouble. And so a user have to spend around about 5 to 6 grand of US dollars to step into music production. So what you can really do is implement your own DAW, provide the computational power using the servers, so that you just do all the complex algorithms and all the complex processing of the audio signals at your backend with your own servers, and provide user with a result whatever he is expecting. You can even simplify the user interface. So that's it. Time to cook some beats. So this is the genre that's known as feature based. It's usually produced around about 100 or 140. So let's just see how does it really work around. So this is a feature based genre, and then I'll just move on with another genre. And we have a tropical beat. This is produced by Kaigo, Rehab, C. These are all the music producers which produce in this particular genre. Even this is near about 100. So I just have one more preview to go on. The mainstream EDM, which I personally like, it's at 128 BPM. So this is gonna be the last one. So that's it.